are recording now, right? So we just recap and we went through these, right? So today will be a relatively short class because we covered a lot, right? We covered a lot this week, and we can move on. We can move on here. So yeah, we went through these already. This is used to measure meter rule. Meter rule is used to measure distance. So you want to remember the names, what they do,
Yes,
and
sir.
pictures of them, right? You want to know the pictures of them. Just match. Remember to match the names with the letters, the particular letters. So this is letter A, which is our meter rule. This is letter B, which is our stopwatch, right? So you want to be able to identify them, study their names, and be able to tell what they are used for. All right, so clamp stand, as we said, is to hold items mounted. Top and balance used to measure mass. Thermometer is used to measure temperature. The Bunsen burner is used as a heat source. The beaker is used to store liquids. The vernier caliper used to measure small distances, right? For example, a ball, right? The ball, we want to find the diameter of a ball, we use our vernier caliper to find that small distance. It is hard to use a meter rule to find that, right? And our ammeter is used to measure current, and our voltmeter is used to measure voltage, right? If you continue in science, you will know the difference between current and voltage, right? It is very interesting, right? And you get a better
Yes,
understanding
sir.
of how JPS transports electricity to you. Right, but we're not getting into that today, right? We're just starting. Okay, so going back to the lab rules, could somebody remind what's the most important rule? Anybody remember the most important rule?
Follow given
Follow.
instruction.
Right. I'm gonna check the chat. What's happening? No eating.
Fall
No.
asleep.
The most important rule is to follow given instructions, right? And we see no eating. So we see no eating, no drinking, follow given instructions. Anybody remember any other lab rule from the last class?
Safety gear. You should
Right?
make sure
So
you wear safety gear.
Always wear a lab coat.
right, safety gear slash lab coat, right? Anybody remember anything else? No eating or drinking. Or what else? And follow
So,
instructions.
after the lab, practice.
What else? Anybody remember anything else?
Always make sure so you got something them off.
Yeah, ensure that the gas outlets are off. What else? Anybody remember? All right. So the last one was no form of horseplay. Why shouldn't we? Should there be no form of horseplay in the lab? Why should there be no form of horseplay? We spoke about it yesterday. Anybody remember?
Say that again, sir.
Why should there be no form of horseplay?
Oh, sir, because I might knock over something, sir.
Right, and
Bam
it
bumps
can break.
over something.
Right. Thank you so much for that. Right?
Because the meter cups are glass.
Yeah. So we have some glass. We have a thermometer as glass. We have the beaker as a glass. So we don't want to destroy these things. These things are very expensive. Right. All right. So now we'll move on to what we plan to complete today. After this, we are finished for this week. We can end the class early. Right. We're
Yes, sir.
moving relatively quickly at a good pace. I like that. Any questions up to this point? Anybody have any questions, any concerns?
Mm-mm.
All right, good.
Sir,
So
is that continuous notes?
yeah, this is in our notes already. So we're just continuing. This is the last thing, right? We'll cover this next week. Area and volume. That's for next week. right? But for today, we're
Yeah,
going,
hold on.
yeah, we'll do that next week. But for this class, particularly, we want to go to the lab format. I encourage you to get a pen and a pencil just to write some of these down, right? Or I could,
My pen.
I'll state them. Don't worry about it. I'll make the notes here, and then you'll get them, right? So the lab format is essentially in this way. So we'll start out with our date as the first thing, then our topic, then our aim. So the topic, of course, is very self-explanatory. The aim is what we want to achieve, right? What we intend to achieve from this experiment, right? The materials is what we're going to use. The lab equipment that we're going to use, the equipment that we will use. Wait, some more persons are coming in. Let's add them quickly. All right. So the lab equipment is what we plan on using to complete our aim or to achieve our aim, what we want to um to 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 achieve, what we want to accomplish. So if we want to prove that the earth is round, right, that would be our aim. Our aim would be to prove that the earth is round. And then our materials are anything that we want to use to prove that. So if we want to go to space, our materials would be our spaceship, right? So we want to prove that the earth is round, right? These are the things that we would use. The method, right? The method now is what we plan on doing, right? The steps that we will take, the steps that we will take to achieve this. As I said, I'll write this down. I'll write this down and send it in your notes, right? And our results, right, are it's very that's self-explanatory, right? The results, what is the the what we get after our method is complete, right? What happens after our method is complete? After we complete our method, what do we have to work with, right? Calculations. Not every lab that we do
Yes.
have calculations. Precautions, no. This is interesting. So these are measures that we put in place, right? Measures that we put in place to ensure, this is a key word that we always use, to ensure that the aim is achieved, right? Ensure that the aim is achieved, right? So measures that we put in place to ensure that the aim of the experiment is achieved. All right, sources of error. Anybody want to guess what this guy is?
What is the cause of the problem that we made or the mistake?
Yeah. So that's a good answer. So that could be a mistake in our when we're doing our method. So it could be possible mistakes. We look on not mistake, but possible.
Sorry, yeah, show your screen.
Yes, I'm showing the screen. You're not seeing it?
No.
You're not seeing it? All right, no problem. I will post the recordings. The recordings will be posted on Google Classroom. So if you need to go back, right, you can go back. I'm recording now. I don't know what to do in this case, but to just tell you that that the recording will posted, right? So our source of error, right? These are things that can come up that can cause problems, right? That can cause issues in our experiment, and we highlight them because we want to avoid them as best as possible, right? So if we go ahead. All right. So let me just show you an experiment, right? Quickly. Let me just stop sharing this for a second. I'm showing you something now, right? Um, so say this is our experiment, right? Please let me know if I'm seeing this. I can click yes, sir, no, sir. I'm not seeing it.
I'm seeing it.
Okay, good.
Yes, sir.
So with go ahead. No question. Yes, this will be posted on YouTube, right? You'll get remember that this will be posted on Google Classroom. So you can go on Google Classroom, get the link, and then it will bring it straight to YouTube. Right. So say this is our um pendulum, right? You will do this, you will get exposure to this experiment in the next 2 weeks, right? We'll go deeper into this experiment. What we're just doing we're just doing some a little introduction to it, right? So we have our experiment and we place our pendulum. This is a mass that we attach to a string. We brought this up last class, right? The more you see it, the more you will be acquainted with it. So just give it time. It's not hard. So we have our mass of say 1 kilogram, right? It is 1 kilogram, and the length of the string. If we decrease the mass, you realize that it goes down or it goes up, right? So we place that 1 kilogram, and we have our length at say 0.5. Let's put that zero. No, let's put that 1 meter. 1 meter, right? This is the aim of this experiment. Now let's go through them. The aim of this experiment is to find how long it takes to come to for it to the pendulum to swing over this side and then to return back, right? Just for argument's sake. So we want to find out how long it would take for the pendulum to go from here over here and then swing back to its original position. So let's try it, right? We have our stopwatch and we'll run the experiment, right? And then we start it, right? So let me do that back over again. I missed it. Let's do that again. Restart this and we run it, right? So it takes approximately, let's just say it takes 1.9 seconds for it to go from the original position to swing over this side, and then to return back. It takes 1.9 seconds. Let's just say that for argument's sake. No, what if the breeze was blowing? Could somebody tell me what would happen if the breeze was blowing?
More force would be pushed on it, sir.
Right. So it would affect it, right?
Yes, sir.
So that would be possible. What would that be?
Excuse me, sir?
What exactly would that be in our, give me 1 second. What would that be? Which one of these would that be? The date, the topic?
Resolution, sir?
No.
Or
Which one of these?
method?
The result.
No. What would the breeze be? We just talk about the breeze, right? What would that be?
Oh,
It would be in this
Oh.
area. The breeze causing affecting it.
Error.
Source of error.
Right. So that would be a source of error. So we would have to what? What would have to do?
Sir, block off the breeze
Right. By what? By doing what?
by covering the area.
By how we cover the area.
I must say now. Sir, I go
Where's
somewhere where there's no breeze.
yeah, but what does the breeze go through? We're in a room. What does the breeze come through?
Oh, the window, sir.
Yeah, so we do what? What would you do?
Close the windows.
Right. So to prevent this error, we close the window. Right. It's just that's just an example of what we would do. Right. So as I said, sources we just look on possible things that could affect our experiment. Right. Possible things that could affect our experiment, and we try our best to fix these. We try our best to fix these. All right. All right. So the limitations are some things that we definitely cannot control, right? We cannot control these limitations. So these can affect our results. Like the breeze can affect our results, but we can control the breeze by closing the windows, right? But we cannot control limitations. So these are some things in our experiment that we cannot control. I will give you the full definitions, right? After we're finished here, things that we cannot control, right? I just add this person. So let's just go through again. We have our date, we have our topic, right? We have our aim. The aim is what we want to achieve from this experiment. We have our materials, which are our lab equipment. We'll use the lab equipment to achieve our aim, right? We have our method, and these are steps that we take to complete our aim, right? We have our results, that's self-explanatory. The calculations, right? If any, not all experiments have calculations. We have our precautions. So our precautions are some things that we put in place, right, to prevent to ensure that the aim is achieved with a little error, right? We want to pull back all the error, or it could be for safety purposes. So what could be for safety purposes in our lab? We spoke about it yesterday from here. Which one of these is for safety? All of them, right?
Yes,
Yes,
sir.
sir. All of
So
them.
so these would classify as precautions. So no experiment, especially these. These are not really precautions, right? But these are precautions because they are for safety. These are precautions to achieve our aim safely. So no experiment should be conducted without safety gear. This is a given precaution, right? And so we're using the Bunsen burner. So we're using the Bunsen burner, right? And gas goes in here. We put in gas, and fire comes out here. A precaution is that we could ensure that all gas outlets are off when we're not using them because we don't want any fire. So these are some of the precautions. These are just examples of the precautions, right? And for the sources of error, right? Sources of error. These are possible mistakes that we could make, possible things that could cause our experiment not to go as planned. Like for example, the breeze affecting a lab, right? And limitations, these are things that we definitely cannot control. We have no control over them, right? And our conclusion. Now, when you're doing a conclusion for a lab, we have to ensure that the conclusion matches up to the aim. So if our aim, say our aim is to prove, for example, the aim is to prove that the earth is round, right? If our aim is to prove that the earth is round, our conclusion should be that what? That the earth is either round or
Earth
not
is
round.
flat.
All right, or the earth is flat, right? Based on our results. So whatever our results are, right, we would state them in our conclusion. So if we say that we are proving to prove that the earth is round, our conclusion should sound like the earth is round, right? Or if you found out that the earth is not round, which is not possible, right? But if so, if anything, any result that you found from your experiment, if you found that out, you would state that in your conclusion, right? Everyone understand? You want me to go through anything again?
Yes, sir. No, sir.
No, sir.
Okay. So, as it relates to our activity that we did yesterday, for those persons who haven't seen the results, you can message me privately as to the grade that you got, okay? If you didn't send the results in the group, you can message me privately as to the grade that you got. Right? For the persons who already sent in their grades in the group, it's okay. I got them, okay? And I saw most persons got all 4 questions right. So that sounds like we're on the right track. And we should be good. We should be good in that regard. Any questions?
No, sir.
All right, so we'll pause here, right? And I will send another activity. Hopefully in the next 10 minutes or so. And you can do it. It doesn't take 5 minutes to do, right? It's just like the last one, very easy, right? So you can just complete that. All right. So all the best, everyone. Enjoy the rest of the day. Remember, I'll send the activity in a few minutes. All right.
Okay, sir. Okay, sir.
Yes, I will send the Google Classroom code in the group. So just check the group. It's in your group. I'll send it in the group in a few again.
Yes, sir.
Okay?
Most of us are already in it.
Yeah, man. Okay, so I'll resend it again. Some persons don't have it. All right. All right. All the best.